Hello everyone. Today we are going to learn 5.2 constant coefficient homogeneous equations. So we know how it looks like a homogeneous equation, right? So other side equal to zero, right? And then we have a constant coefficient, all right? Okay, so we did that last section, linear second order or second order linear differential equation, right? So the form looks like this. Y prime plus the polynomial y prime, y second prime, y second prime plus polynomial y prime plus cube x, y equal to the function f of x, yeah? So like decreasing the derivative, right? So second, first, zero, right? Okay. This is the form of, this is, sounds weird. This is a form of linear second order differential equation, right? So homogeneous equation, other side is zero, right? Okay, now we add the constant coefficient equation. Yeah, constant coefficient basically, right? So they don't have constant coefficient. That is a polynomial, right? So related with x, yeah? But now constant, so just real numbers, yeah? A cannot be equal to zero. If A equal to zero, then that is the first linear order, right? Okay, so we have form of constant coefficient equation here. Instead of a polynomial, we just add real numbers there for each term. Yeah. Then once again, homogeneous equation, we set other side equal to zero. Yeah. Okay. Now, let us take a look if we have the form of equation, which is y equal to e to the r times x. Yeah. So r is a constant, right? Okay. Now we want to find the derivative of this equation, right? Then we have e to the rx, and since r is constant, so times r, right? Okay, what about the we derivative again, right? So y prime equal to, then we do again e to the rx times r again, right? So we have r squared. Make sense? Okay, now we have the form, the coefficient, the constant coefficient equation in linear second order, right? Okay, look, so we have a y second prime plus b y prime plus c y, right? Equal to, we keep the a and the y prime, we plug in there, right? And b y prime, we plug in there, yeah? C, then what's the y? Y is e to the r squared. No, sorry, rx, yeah? We have that. Okay, now every term e to the rx, there is a common factor, so we factor out. Then the remaining is ar squared plus br plus c. Okay, now we set it up this one as a p of r because we can see that r squared, then r, and r to the zero power is decreasing, right? Okay, so we say that this one is characteristic polynomial. Yeah. So we're using polynomial normally in terms of x, yeah? Then ax squared plus bx plus c, right? But in that case, we are using P of R. So we are using AR squared plus BR plus C. Yeah? Okay. Now, P of R equal to 0. We say that it's equation because we have two sides, right? And we say the characteristic equation. All right? Okay. Now, we set it up y equal to e to the rx. Solution of, normally we have that, right? So original equation is a solution of that differential equation, right? So in that case, we have constant coefficient. Second, try to remember, second linear order differential equation, right? Yeah. And then we have IFF means if and only if, yeah? P of R equal to 0. Make sense? Okay. Now, we've seen this one before, right? So polynomial quadratic formula, right? Because we have a, if we using in terms of x, right? I introduced you earlier, right? Okay, now then we can find the solution, right? So we are using R instead of X, right? Then how do you find the solution? Which is, in that case, is root, same as solution, right? So minus b plus minus square root of b squared minus 4ac over 2a, 2a, all the way to a, right? Okay, then we have three cases. The first one, inside the square root, we can find it quickly, right? So inside is greater than 0. We notice that there is two distinct real number of solutions, right? Okay, so two distinct means not same, which is different answer, right? So for example, a equal to 1/2, b equal to, sorry, you might get confused. R, the first R equal to 1/2, second answer is 2, like that, right? Two different answer, okay? In case 2, if inside equal to 0, then there is a repeated real root. So must be r equal to 2 and also r equal to 2, another r equal to 2, right? Okay, so inside we calculate is less than 0, then there is a complex root, right? Why? Because we knew that inside the square root cannot be negative, right? If we have a negative, that means negative, right? There is complex, which is I, right? That's why we have complex root, yeah? Okay, so we are using three cases to find the solutions in this section. Make sense? Okay, let us do this. Am I recording? Okay, good. All right, so case number 1, we have distinct real roots. Root means solution, right? And distinct means not same. Means that two different solutions, yeah? Okay, now the first one, we have a general solution. Find the general solution of the linear second order, which is y second prime plus 6y prime plus 5y equal to 0. And then second one, we have initial value problem, right? Okay, so let us do this one. So we have the linear second order questions, right? The differential equation, yeah? Then we can set it up, right? So we have, if they have equal to 0, then there is a solution, right? Okay, so copy. All right. Okay, then P of R, we need to set it up. Then find R, right? So there will be P of R, which is, there will be R squared plus 6R plus 5R equal to 0, right? So let me writing out. So R squared plus 6R plus 5R equal to 0. Oh, no, 5, yeah? All right, is it factorable? Can you factor out? So we have R times R and positive. So 5 times 1 is 5, and we add them, get 6R, right? Okay, in that case, R plus 5 equal to 0, R plus 1 equal to 0. So R equal to negative 5, R equal to negative 1, right? Okay, then we are going to using this one, y equal to e to the rx is a solution, right? Okay, so y to the what? Y to the e to the r, in the case negative 1x, and we have another one, distinct to two solution, right? So there will be y to equal to e to the r, in the case is negative 5x, yeah? Okay, so let's label y sub 1 in the case, y sub 2 in the case, yeah? Okay, then from the previously we have linear combination, right? So we have y equal to c sub 1, y sub 1, right? Plus c sub 2, y sub 2. It's, oh, scare me. Something dropped. So it's a solution of the homogeneous equation, right? Okay. So this is a general solution, right? Okay. There will be y equal to c sub 1, y sub 1, which is e to the negative x, plus c sub 2, y sub 2, which is e to the negative 5x. Yeah? General solution. Make sense? All right. Second part. Let us do the initial value problem. So given information, we need to solve such as C, and we are going to find particular solution, right? Okay, let us do this. All right, so we have y equal to c sub 1 e to the negative x plus c sub 2 e to the negative 5x. What is y prime? Let us find the y prime equal to e to the negative x, and then times negative 1, right? So negative c sub 1 plus we have e to the negative 5x and times negative 5. So negative 5 c sub 2, right? Okay, now we are using the conditions, right? So we have y of 0 equal to 3, y prime of 0 equal to negative 1, right? So y of 0 equal to, so we have c sub 1 e to the, that means x equal to 0, right? So e to the negative 0 plus c sub 2 e to the 0 as well, right? Okay, then what do you get? So, hold on 1 second. We have y of 0 equal to 3, right? So we have equal to 3, yeah? Then we get c sub 1 plus c sub 2 equal to 3, right? Okay, now we have y prime of 0. In that case, it's 0, 2, right? I'm sorry, x 2. All right, then we using the blue. Let me using blue. So negative c sub 1 e to the 0 power minus 5 c sub 2 e to the 0 power, right? Equal to negative 1. Okay, then there will be negative c sub 1 minus 5 c sub 2 equal to negative 1, right? So all together we have, so we have a c sub 1 plus a c sub 2 equal to 3. Ooh. And we have negative c sub 1 minus 5 c sub 2 equal to negative 1, right? Okay, we solve. So this will be 0. So we have negative 4 c2, c sub 2. Same color. Negative 4 c sub 2 equal to positive 2, right? Then c sub 2 will be what? Negative 1/2. Very good. Okay, now we can use anything to find c sub 1, right? So we had c sub 1 plus c sub 2 equal to 3. So we substitute. So we have c sub 1 minus 1/2 equal to 3. Yeah. So what's the c sub 1? So c sub 1 equal to 3 plus 1/2, which is 7 over 2, right? Yeah. Okay. So we can conclude the solution, particular solution, y equal to c sub 1 e to the, where is it? Negative x plus c sub 2 e to the negative 5x. So that will be c sub 1, 7 over 2 e to the negative x plus c sub 2, negative 1/2 and e to the negative 5x. Yeah, particular solution. Is it good? All right. All right, so now case number 2, we have a repeated real root. So then in that case, the inside the square root from the quadratic formula, right? B squared minus 4AC exactly 0, right? Yeah. Okay, then look, I don't want to spend a lot of time for this showing the conclusion, right? And I don't want to make also mistake, right? So I'm gonna just using the note here. Okay, so we have a y second prime plus b y prime plus c y equal to 0 has a arbitrary, right? Repeated root In that case, we are using R sub 1 instead of R, yeah? Because we want to make distinct with R and then R sub 1. R sub 1, in that case, is a repeated root, okay? Okay, since we have repeated root R sub 1, so R minus R sub 1 quantity squared, right? So we solve, then we have a repeated, yeah? Okay, so if we have the formula a minus b to the quantity squared, right? So we have a squared minus 2ab plus b squared, right? So we are using that. Okay, now we distribute the a, then we get this one. Okay, now we arrange r squared with r and r to the 0 power, right? Okay, then that will be 2a r sub 1 will be b in that case, right? Corresponding b, yeah? And a sub r squared will be c, right? Corresponding with the c, right? Okay, now this one equal to, we have start over, right? So like this, yeah. Okay, so a r squared minus 2 r sub 1 times r plus r sub 1 squared. Okay, now we divide by a each term, both sides, right? Then we get y second prime plus b over a, y prime plus c over a, y equal to right side only the whatever inside in the parentheses, right? Okay, this is the right side. Okay, then we have b equal to 2ar sub 1 here, right? Okay, and then we have a c equal to ar sub 1 squared from here, right? Okay, then the left side, so a's cancel out, so we have a 2r sub 1 r here. We can express y prime, yeah? And y second prime is r squared, right? And then the c, which is a r sub 1 squared. So we have r sub 1 squared and then a is canceled out, right? Make sense? So left side, we have one. Yeah. So right side, same as the left side. Okay, then once again, r squared we can express as y second prime, like earlier, right? And then r y prime. And then this is like a constant, right? So we have just y, right? So it means that the no derivative, right? So can you see that? Higher derivative, second order, and then first, and then no derivative, zero derivative, right? Okay, now we have equal to 0. Okay, so once again, we have a polynomial p of r sub 1 equal to 0. Then y equal to r sub 1x is a solution of that coefficient. Uh, made a noise, so I forgot what to say. The coefficient, coefficient, the equation, right? Yeah, of linear second order, the differential equation. Yeah. Okay, now we have more. Whew. All right, so we have a y equal to, let's talk about u e to the r sub 1 x. We know r sub 1 is the root, repeated root, right? And then we say that u is a function of x. Okay, so u is a function of x. If we derivative y prime, then we are using product rule, so we consider u as f, e to the r sub 1 x will be g, right? So product rule, f prime g plus f g prime, right? Okay, so we follow that. There will be u prime, and keep the second one, and plus, and we keep the first one u, and then we derivative of second one, e to the r sub 1 x, then r sub 1 times, yeah? That's how we got it by using product rule. Okay, y second prime. So from y prime, also we are using product rule again. So f prime, use second prime, keep the second one plus f, which is u prime, and then g prime, second prime, which is e to the r sub x, then times r sub 1, yeah? Okay, we finished that. And second term, product rule again, because u is a function of x, right? Okay, so f prime, so r sub 1, u prime, keep the second one, and f, we keep that, and then e to the r sub 1 x times second prime r sub 1. Yeah, that's how they got it. Good. All right, so we have, look, we have more. We are using this one. Okay, now we just found what is y second prime, what is y prime, and then we are using y equal to u e to the r sub 1 x. Okay, so we substitute y second prime, substitute y prime, substitute y, then we combine like terms, so everything is 0, so we have u prime r sub 1 x, yeah? Just say uh-huh, yeah? I did not hear you. Uh-huh. Okay, very good. All right, so everything all together, this one equal to that. Say uh-huh. Okay, very good. So we have, not you have, we have y second prime minus not e, that's Korean e, 2 r sub 1 y prime plus r sub 1 squared y equal to u second prime e to the r sub 1 x, yeah? We say that, almost done, hanging there. So we say that y equal to u e to the r sub 1 x is a solution of that if only if u second prime equal to 0. All right, so we check that u equal to c sub 1 plus c sub 2x. Then u prime will be, first term is 0, second term is c sub 2, right? We derivative, right? If we have u prime, we want to make a u second prime constant, so it's 0, right? Okay, now what we are doing, we have y equal to u e to the r sub 1, x is a solution. We conclude. So this is the solution of, yeah? So if we have a repeated root, generally we can just using this one. Yeah. This is, we show that everything. Clear? All right. So we have a question, so let's do it. So find general solution. Okay. So let's find out. So A. So we have y second prime plus 6y prime plus 9y equal to 0. All right, so we can change the P of R, right? So R squared plus 6R. Let me just writing. So R squared plus 6R plus 9 equal to 0, right? Okay, now can we factor out? Can you try? Okay, nice, right? So 3 times 3, which is 9, add them, which is 6. Very good. So we have r plus 3 equal to 0 means r equal to negative 3 and repeated, right? Repeated root. Repeated. Okay, so then we can use that formula or form, yeah. So that would be y equal to u, which is e to the r sub 1 repeating, negative 3 in the case, x, yeah? Then what's the u? U is c sub 1 plus c sub 2x, yeah? Make sense? And let me just using this one. I can just saying that, right? So this will be u. All right, so we have y equal to e to the negative 3x. Then there will be y equal to c sub 1 plus c sub 2x e to the negative 3x, yeah? All right, so we call this as a general solution. Okay, let's find out such as c sub 1, such as c sub 2. Yeah. Okay, so let me bring this one. Copy. Yeah, we can writing out e to the negative 3x and c sub 1 plus c sub 2x. Same, right? All right, so let's distribute. So we will get e to the negative 3x and constant c sub 1 plus c sub 2x e to the negative 3x, yeah? Okay, so y prime. So the first term will be c sub 1 e to the negative 3x and times negative 3, right? Plus second term, we have x. So f g, f prime g plus f g prime. All right. So we get 1, right? F prime, which is 1. So we have a c sub 2, g e to the negative 3x plus f c sub 2x g prime e to the negative 3x and times negative 3, right? So times negative 3, yeah? Make sure I don't make a mistake, right? Okay, now we are using the initial value problem, right? So we have y of 0 equal to 3 and y prime of 0 equal to negative 1, right? Okay, so that means x, right? So we have y of, uh, let me using this one, right? Yeah, so I have to have 0 equal to c sub 1 e to the 0, directly 0 plus c sub 2, 0 e to the 0 equal to 3, right? Okay, so easy. C sub 1 equal to 3, yeah? Okay, how about y prime of 0? So we have, yeah, this is 0, right? Okay, so there will be negative 3 c sub 1 e to the 0 plus c sub 2 e to the 0 minus 3 c sub 2 0. Everything is 0 in the case, yeah? Equal to negative 1, right? Okay, now we have 3 c sub 1 plus c sub 2 equal to negative 1, but c sub 1 equal to 3, right? So we are using that. So 3 times 3 plus c sub 2 equal to negative 1. Oh, make a mistake, right? So we have a negative, so missing negative there. Okay, so we have a negative 9 plus c sub 2 equal to negative 1. Then c sub 2 will be positive 8. Yeah, good. Okay, so we can conclude everything. So we have y equal to c sub 1 plus c sub 2x, right? E to the negative 3x. Yeah, from the general solution, right? So e to the negative 3x. E to the negative 3x, which is c sub 1, we have 3 and plus c sub 2, which is 8x, and e to the negative 3x, yeah? That will be particular solution, yeah? Make sense? Very good. Okay, now case 3, complex conjugate root. All right? Okay, so we have constant coefficient, linear second order differential equation. Yeah? Okay, now we have e to the, this we called lambda, Greek letter I, which is a complex number, right? And we called this is omega, looks like a W, but omega, okay? So no, not I, lambda plus I omega times x, we can split with the distribute. So lambda x, and then we split I omega x, yeah? And if we have a negative, we keep the negative there, right? Okay, now let's say that R sub 1, so don't get confused with the R sub 1 earlier. We can just using the notation, yeah? So R sub 1 earlier, repeated root, right? In that case, just a complex root, just the first solution, yeah? This is the second solution, okay? So the first one, we have lambda minus, positive I omega, and then second one is negative, yeah? Those are root. Okay, then we can prove how this can be root, right? All right, so we have since R sub 1, R sub 2 are root, yeah, then we can express this way, right? Then we can set up the 0, then these are the roots, which is the solution, right? Okay, now, since R sub 1 equal to lambda plus I omega and R sub 2 equal to lambda minus I omega, right? I kept saying that W, so I have to think. All right, then we distribute, then we get that. And we distribute, then we got that, right? Okay, then can you recognize we have A minus B in the case times A plus B, right? Okay, then there will be A square minus B square, yeah, in pink, yeah? So there will be R minus lambda quantity squared minus lambda omega, no, lambda, sorry, I omega quantity squared, right? Okay, so uh, then we expand, right? If we expand, that would be R squared minus 2 times R lambda plus lambda square, right? Yeah. And then this one I square omega square, right? Okay, now, so we expand from this one, right? But then what's the I square? I square is -1, so we change the sign plus, yeah? And then for your reference, I wrote down about the I here. Okay, now we can express R square, which is YW, not crazy. Y second prime, and we can express R as Y first prime, right? And look, so we express this one like this, yeah? This one with that. So R square Y second prime minus we keep this 2 lambda R, which is Y prime, and omega square plus lambda square, which is a constant. So we can keep that constant with Y. Yeah. Now make it equal to 0. Then we start for, we divide by A, both sides. Then we have whatever just inside, right? Okay, good. Now, let Y equal to U times E to the lambda X. So where U equal to function of X, like earlier, we had U e to the negative R X, yeah? Okay, now we derivative, then product rule, right? Because U is the function of X. So U prime, that's the F prime, keep the G plus F G prime. So E to the lambda X, and then lambda is constant, so times lambda, right? That's how they got it. Okay, now second prime, yeah? So product rule again, term by term. So we have F prime, so U second prime, and G, keep that, plus F, U prime, then G prime, E to the lambda X times the lambda, right? So that's how they got it here. Okay, second term, we do product rule again. So F prime, which is U prime with the lambda, and keep the E to the lambda X, plus we have G prime, right? So keep the first lambda U, then E to the lambda X times lambda. That's why lambda squared there, yeah? Okay, now from here we have, right? So from here, okay, so we substitute what is the y second prime? We just found here, right? What is the y prime? We just found here. So substitute there. And then y, just do y. Yeah, plug in here. Okay, now we combine like term. So we get u prime plus omega square u equal to 0. Okay, now let's find out whether this is the true statement or not. Okay, so let u equal to c sub 1 cosine omega x plus c sub 2 sine omega x. Yeah. Okay, then u prime will be what's the cosine omega x? So omega, we treat them as constant, right? So minus sine omega x. Then we have a c sub 1, keep that, and then times omega derivative, right? Okay, what's the derivative of sine omega x? That's cosine omega x, then times omega, right? Because constant. And then c sub 2 is there, right? Okay, u second prime. So looking at the u prime, we derivative again, right? So what's the sine omega x? With a minus, right? So minus cosine omega x and times omega, right? That's why they got the omega squared. And we keep that c sub 1. Yeah. Okay, now second term, what's the derivative of cosine omega x? That's the negative sine omega x and times omega. That's how they got it, omega square, and keep the c sub 2, right? Okay. Now, we want to show that this one equal to 0, right? Whether true statement or not. So that is the one. Make sense? Yeah, a little bit ugly, right? So no space. Okay, so u prime. We are using u prime here and omega square here. And then u, so we are using u this one here, right? Then we simplify. So if we distribute, then this one cancel out and this one cancel out, right? Which is 0. Make sense? Okay, now we conclude y equal to u e to the lambda x. There will be, what's the u? U is c sub 1 cosine omega x plus c sub 2 sine omega x here, right? Then e to the lambda x. Okay, so this is we switch over in the back, right? So we get the same. So we are using this form for complex roots. Make sense? Okay. One more things. If we have like a quadratic, right? So we have two roots in complex roots, right? Okay, so one is positive and then b squared minus a 4ac in the square root. Then I want to factor out with the negative sign that negative parentheses 4ac minus b squared, right? Because we multiply that, we get negative 4ac plus b squared, right? Okay, one is positive, one is negative. We take out with I, right? Because negative. Yeah, make sense? Okay, then following everything, right? Okay, so 2a is the common denominator, so we can split with two fraction. Make sense? So one is positive, one is negative with I. Make sense to you? The negative, I mean, I come from the negative inside the square root, right? Okay, now, we can express nice way I sub 1, first solution we can express as lambda plus I omega, and then R square. This one what we did earlier, right? In the beginning, right? Okay, so lambda equal to negative 2a, the first term, and then omega will be second term. Yeah, and I is still there, right? Make sense? Okay, so this one we called Euler's formula, e to the I theta equal to cosine theta plus I sine theta. All right? Okay. Let us do this question. This will be last question for this section. So let us do that. So we have find the general solution of the linear second order of differential equation, right? Okay, so let's check that whether there is complex root or not. So we checked b squared minus 4ac. So b squared minus 4 times a times c, which is negative 36, which is less than 0. So they must be have complex root, yeah? Okay, then, hold on. We are using the information, right? So y equal to the complex root. Copy. All right. So we can find the lambda easily, right? So what's the lambda? Let me copy too. Okay, I sub 1, which is lambda, right? So let me find out the lambda first. How about lambda first one? No, it's the same lambda, right? Does not have to be first one. So lambda equal to negative b. So we have negative b, which is a, b, c. So we get negative b, which is negative 4, over 2a, which is negative 1/2? No, 2, right? Okay, how about omega? So we have 4 times a, 1, c, 13 minus b squared, 4 squared, uh, over 2a, right? Yeah, then what do you get? 16 and then 3, yeah? Okay, now we can just see using that y equal to the form lambda x, so 3 e to the 3x, and c sub 1 cosine omega, which is 3x, plus c sub 2 sine omega x, which is 3x, which is general solution. Yeah. Okay, so from general solution, so we want to find particular solution, right? Copy. Okay, so y prime, right? Okay, so let's make a product, right? So product. So f prime, which is, hold on 1 second. Do I make a mistake? It's a 2. It's a 3 or 2. I made a mistake, huh? Omega. Let me double check. 3x, 3x. Okay. Negative 2x. Yeah, lambda equal to negative 2x. Yeah? Lambda. I was using omega there, right? Sorry about that. Good thing I'm catching that up. Yeah. So this is lambda x. So lambda in the case is negative 2, right? And then I don't make a mistake beside that, right? So negative 2x. Okay? All right. So y prime we get e to the 3x and times of 3, right? Oh no, to negative 2, sorry. Sorry about that. Crazy. So negative 2, right? Okay, so do again. So e to the negative 2x and so we are using product rule f prime g. So negative 2 g c sub 1 cosine 3x plus c sub 2 sine 3x. Yeah. And no space and plus f g prime. So we get f e to the negative 2x g prime term by term, right? So we have c sub 1 derivative of cosine 3x with negative sine 3x and times of 3, right? And plus second term, so derivative of sine is cosine 3x and 3 c sub 2. Okay, now we are using the initial value, so y of 0 equal to 2 is x, right? So this is x. Okay, there will be y of 0 equal to e to the 0, c sub 1 cosine 0 plus c sub 2 sine 0 equal to 2, right? Okay, then there will be cosine 0 is 0 and cosine 0 is the 1, sine 0 is 0, right? So we have 1 times c sub 1 cosine 0 equal to 2, which is c sub 1 equal to 2, right? Okay, now this is 1. Y prime of 0, which is negative 3, right? Okay, so y prime of 0 equal to, we have negative 2e to the 0 power and c sub 1 cosine 0 plus c sub 2 sine 0 plus e to the 0 power negative 3 sine 0 plus 3 cosine 0. Yeah? Okay, there will be negative. Hold on 1 second. Let's sine 0 is 0. So we have negative 2. Oh, equal to what? Negative 3, right? So there will be negative 2 and c sub 1 cosine 0 plus 1, then 3 cosine 0 equal to negative 3, right? Missing, hold on 1 second, missing c sub 1. So negative 3 c sub 1 is missing, right? So let me write down -3 C sub 1. And +3 C sub 2, right? Okay, so -2, I am doing this one, -2 C sub 1 cosine 0, yeah? Then 3 C sub 2 cosine 0, right? So 3 C sub 2 cosine 0 equal to -3, right? Okay. So we knew this is 1, right? So this is 1. So -2 C sub 1 is given, which is 2. And we have +3 C sub 2 equal to -3. So -4 plus 3 C sub 2 equal to -3. C sub 2 will be what? So move, so +1 divided by 3, so 1/3, yeah? Okay, no space, just I need to conclude, right? So that will be, we have y equal to general solution. Copy? So we have y equal to e to the -2x, c sub 1, which is 2 cosine 3x, plus c sub 2, 1/3 sine 3x. Yeah, we call this is a particular solution, right? Okay, so all summary about case number 1, case number 2, case number 3 is here, all right? Okay, thank you for watching. I will see you in next video. Bye.